just like someone's let's say that the rate at which Nigeria is earning money depends on how much we already have in our reserve. So it is not. Okay, this is not sufficient. And the second one, so we have two rates, so we can have relative rate. Remember that what we are looking for is rate, so we can have the relative rate. So this is sufficient in as much as we can calculate the relative rate. Is S a negative number? Of course, this must be negative for 9s to be greater than 10s. I used to think this in one funny way before. The only thing that can make a higher value to be greater than a lower value is that that thing is a bad thing to be better. So if you go to a country where corruption is less, it will be better than a country where corruption is high. So 9s is greater than 10s because times 10 means that we are increasing, so in negative value. So this must be negative for it to happen. So 9s is greater than 10s. S plus 3 is positive. Is not sufficient because of the scenario. Consider this. Consider 1 when s is 1. Okay, s plus 3 is positive. Okay, s plus 3 is positive. 1 plus 3 is positive. 1 plus 3 is positive. Is that not? But s can also be minus 2. Minus 2 plus 3. See, this is wrong, right? 1 plus 3 is positive. Minus 2 plus 3 is still positive. So it doesn't matter. S can be both positive and negative. That is why it's not sufficient. Let's quickly do number 14. If I and j are integers, is I plus j even integer? If I is less than 10, is it 9? Is it 6? Is it 7? We don't know. Even here, it didn't say that they are positive integers, so I can also be negative numbers. So this is not sufficient because it can take several values. If I equals j means, let's say, if 3 plus 3 is even, if it's also even plus even, 2 plus 2 is 4, is so also even. So this is sufficient. I want us to quickly do number 15. In this number 15, I want you to notice that when we take cube root, when we take like the third root, which we can also write this way. This is the third root of 8, is 2. Is a certain value. But we take the square root of 4. The square root of 4. Remember that we can also write it this way. The square root of 4 is minus 2 or 2. Generally, if the root is odd, that is the cube root, the fifth root, like the fifth root of 32 is 2. If the root is odd, we have a specific value. If the root is even number, we have plus or minus. Because we have the fifth root of w is 64, that means we can solve it. So the fifth root of w is 64, right? It means we have a specific value, not 2. This is sufficient. The 15th root of w is 4. We also have a specific value. This is also sufficient. The only thing this question is testing, or the main thing is testing, is the ability to differentiate between when the root is even and when the root is odd. If the root is even, you have plus or minus. If the root is odd, you have only specific value. So both of them are sufficient. Let's do number 16. Why are there many questions here? Okay, number 16. If car S follows car Y across a certain bridge that is half mile long, how many seconds did it take car S to travel across the bridge? Car S drove onto the bridge exactly 3 seconds after car Y drove onto the bridge, and drove off the bridge exactly 2 seconds after car Y drove off the bridge. Okay, so certainly, if we know Y, we will know S. If we know S, we know Y. But we know here we know neither S nor Y, so this is not sufficient. Can Y travel across the bridge at a constant speed of 30 miles per hour? In that case, we know the speed of Y. So we know this is going to give us speed of Y. But it's not sufficient because we are looking for S. Now that both S and Y are, now that statement 1 and statement 2 are not sufficient, we can now combine the two statements together. When we combine the two statements together, what happened? What happened is that we can know S from Y. So if you add statement 2 to statement 1, we can now know the speed of S. So both of them combine together. Alright, it's your turn now. Do number 17.
Okay. 1 is not sufficient alone. Let me see if 2 is sufficient. Is it if n plus or divided by? Okay.
Is if m plus k equals m, what is the value of k? Oh, I thought it's a straightforward question. It's not entirely straightforward. Let's do it together. If n,
So 2 alone is sufficient.
yes, 2 is sufficient. 2 is sufficient because if n plus, what we are looking for here, we are looking for k, and from this statement here we can see that k equals m minus n. Is that? No, yes, k equals m minus n. And from statement 2 we can also see that m minus n equals minus 10. So the most important thing is that we know m minus n. The main reason why statement 1 is not sufficient is that n equals 10. So what happened to m? So we don't know m, and there's no way to figure it out. No way to figure out m minus n. Now solving number 18. Number 18. The number of seats in the first row of an auditorium. Try it. Let me see. It's something we have done in problem solving, not here, but in problem solving.
One is sufficient.
Okay.
And two is sufficient. So both are sufficient on their own.
Okay. Why is one sufficient?
So one is sufficient. So it's like x plus, I don't know, it's like, is it factor something about, anyway, logically and mathematically sufficient. I don't know how to explain it, but it's like 18
Wahala.
plus 2, 18 plus 2 plus 2. So it's like 18, 18, 18. Okay, so you say our row 0 is 18. Our row 1 is 18 plus 2 to the raised to power 1. Our row 2 is 18 plus 2 raised to the power of 2 times 2, blah blah blah. So at row 27, I can easily calculate the number of zeros.
Yes, the thing is,
That's
but you also need to be fluent enough to. You're supposed to be fluent enough to answer the question. I mean, it's something that you're supposed to know. This is arithmetic progression. This is arithmetic progression, and what you are saying, if we have, so we have the first term. The first term a is 18. This anything after is said is d, the common difference. The common difference is 2. What is the total number? The number of rows of seats in the auditorium. So n is 27. So statement 1 probably we use this formula that states s equals n over 2a plus m minus 1d. So we have everything here needed to solve this. We have n, we have d, so we have a, the first term. So that is sufficient. Statement 2 is even the one we use most of the time. Last week we used it at least 3 different times while solving the sum. The number of seats in the last row is 70. So we use s, the other sum formula, s equals n over 2, the first plus the last, because we have the last, so we added. We already have the first. We already have n. No, we don't have n. Wait, the number of seats in the last row is 70. Okay, the number of seats in the last row is 70. So what happened to n? The number of seats in the auditorium is 27. Okay, the number of seats in the first row of the auditorium is 18, and the number of seats, so we can use n, we can use this other formula. So this is the formula, but we don't know n. But then we can use that. We need to find which term un equals a plus n minus 1d. Okay, we use this to find n. Yes, because n is not given. So let it not be that I'm not telling you that you use 27, but if you use this formula, you notice the last row is 70. This is like this: 70 equals a 18 plus n minus 1, d is times 2. You see that we have everything set up here. All we need is to calculate this and we get our n. If we get our n, we will put it here. Is data sufficiency? We don't really need to solve. Alright, now going to the next question.